fundamental discussions and narrow the focus down to rail and truck movements and measurement on hydrocarbons. And let's get, there we go. Okay, so the quick version of who Sky is, if you haven't had those introductions and what we do, you can see the variety of products and applications that we're involved with, from a design, build, or concept ideas to fabrication and installation and assembly and ongoing services. So a variety of refined fuel applications along with crude oils, really depending on your niche. Some of the locations that we have installations, and of course the map is not up to date, but we're in our 15th year. We're in Alberta, or a Canadian-based company with offices within Canada, the US, and Mexico, and employees within Canada and Mexico today. And our technicians service and support all of these products on location throughout. So we're very happy to have that installation base, and we do get to meet a lot of people and clients and a variety of applications. Again, here's some perspective on our processes and how we would support the industry from concept to execution. And a bit of a brief list of some of our clients through the years. Okay, to the topic at hand. What we're looking at covering here today is a bit of a basic or fundamental description of transloading and what that means for the people that we work with for the most part, and hopefully there's some relevance for you. And the goal we'll try and achieve here is, first off, if anything, hopefully you can take away an understanding from our perspective what transloading of hydrocarbons means or is, and then really what are some of your options relevant to a variety of these products, be it crude, diesel, gasoline, and propanes. And to put it quite simply, transloading, and just to pull it out of Wikipedia, is really just the process of transferring shipments from one mode of transportation to another. And to keep it that simple, what we're going to try and do is give some perspective through the supply chain that there's many different scenarios that these commodities can be going in and out of those modes of transportation. And what we'll try and show you is some solutions for those, not only in the transfer of, but the measurement of the products. So certainly on the crude oil side, you've got your production, and then we have refining, then we transition off to the refined fuels. And as you all know, in the variety of industries that you're in, the products can go in and out of those modes of transportation many times. So we'll try and clarify some of that for you.
John, what's an example of that, as far as, you know, an experience that we've had where we've loaded LPG here in Canada and then it's arrived in Mexico?
Yeah, no, it certainly happened for us. Canada, with low commodity prices, we're really a source location for products. So we've literally loaded LPG into rail cars from trucks in Canada or Alberta and offloaded those same rail cars in Mexico. So it's been, and that was to our surprise. So it's a big world, but it isn't really at times. So
we hit that last mile.
Certainly do.
Mexico.
Yeah, the final destination is typically retail consumer, but some industrial. And I'll try and show examples of that throughout. So we go right back to the beginning source for perspective for some folks. Maybe we've got some people that are in the trading firms or commodity traders or et cetera. This is really where it all starts. You know, we've got well site production volumes. They're going to be cleaned up somewhat to a clean oil state, and literally you're transloading that in a sense, or transferring it, potentially metering it for the most part, a lot of times into trucks. Could be into pipelines, it could be into trucks and pipelines or some sort of infrastructure. But the point is that throughout the supply chain, rail certainly does play a factor. So we're going to reference rail and truck specifically on this webinar and try and give you some examples of how we execute those applications and a variety of builds that we do.
Where rail fits into the supply chain process.
You bet. Yeah. This is a good little diagram of the variety of transload, if you will, or the variety of transfer solutions that can happen. We build LAC systems, of course, as well, and we do get involved in ships, but truck and rail is what we're going to focus on, and it can go many times in those farms.
What about, have we engaged in any type of barge or marine? What does that look like?
Yeah, very similar at times. Potentially ship and barge might be transferred in higher volumes, and larger equipment, certainly. And it's all economies of scale, right? We certainly know that pipeline is an economy of scale, the most efficient form of transfer, best bang for your buck, if you will. Then really, depending on geographic locations of consumer and provider, ships play a part, barges play a part, then you move into rail, and then you start moving into the trucks. And so many times it's in and out of those more than once. So, you know, that typically, or at a very simple level, we have trailer units, rapid deployment, lower cost trailer units, and these can be executed quickly, very common. But we'll show examples of how this is morphing into modular build, stationary equipment, and then larger terminal facilities. Then we'll try and point out some of the things to keep in mind in these scenarios. And of course, final destination, really on the refined product side, we're right down to retail consumers. And then I'm going to include, of course, the LPG or high vapor pressure applications of refined products. Very similar at times how these commodities are moved, or the propanes are moved, and the butanes. And they do go in and out of different forms of shipment, pipe, truck, rail, and ship. And we'll try and work on some of those fundamentals here also. There we are, we're transitioning from rail to truck for final delivery. And that's an example of a transloader trailer unit, portable unit, to execute that task. And again, back down to retail consumers or industrial. You know, there's a variety of industrial applications outside of the retail, home heating or offices or power generation, etc. So let's move on to the next phase of transloading. We've talked a little bit about what it really means in the hydrocarbon space relevant to crudes and refined products, in that it's a form of transfer and measurement of it. I think we'll move into a little more detailed perspective of the techniques used, or the equipment used.
Do we want to take a couple questions? Was there any questions in there that we wanted to, maybe prior to getting into this next
Sure.
piece?
Let me have a quick look. Let's see. Well, okay, what do you got, Grace?
Well, from James here, will you be going over economics in comparison of average cost per barrel to pipeline to understand the difference?
Well, I think I would have to, what I can do is give you some perspective of cost, and we'll keep that in general terms, and certainly let's follow up outside of the webinar to try and put some of that in play for you. I'm not going to have economics on pipeline movements or ship and rates. We can certainly tell you our costs for the equipment to do the transfer and measurement in a variety of scenarios, but I don't understand the rate costs on the commodities. We get into the solution to design build portion, but we can certainly talk in the future, James. So typical methods of transfer. Again, we're going to keep this very, very simple and narrow right now, and focus in on general categories, if you will. So from a crude oil perspective or a condensate perspective, when we start to look at designing, and our engineering guys have to get involved there now, and we've got to put some clarity to the application, we categorize crude oil and condensates, stabilized condensates, as a low vapor pressure product or a liquid form, and they're going to be pumped. Now we separate crude and condensate just a little bit from the refined products because it is raw crude, and there could be solids, it could be sour, it could be water. There's a variety of contaminants that can be in that product that we deal with just a little bit differently than we would the refines. The refines certainly are coming out of their consumer spec, they're to a certain quality level. So the equipment is a little different, but very similar, but it is a pumped and inline metered application. So we categorize low vapor pressure or stabilized liquids as one type of transload application. And then the other would be high vapor pressure product or non-stabilized product that's under pressure when we transfer it. And that would be an example. An example would be propane. And most often when we're doing truck and rail transfers, we're using a compressor and hydraulic differential pressure. And we'll show some examples of that. And you can see my little notes at the bottom, my lawyers speak, where, you know, and I'd like you to, if you get a chance, you can grab this link. We did a webinar, our first webinar, that was very specific, and it's on our YouTube channel, to LPG and butane measurement and transfer and transloading. So we've got a whole hour session where we went into detail on the components, the applications, pressure properties. But for today's high-level discussion, we're going to have two categories: low vapor pressure pumped liquids, high vapor pressure compressed gas or liquid moved through hydraulic differential. Okay, so we talked, and I'll show more examples of how we're moving with compressors and pumps, but the other component to these transfers, because there's ownership changes, there's government involvements on where the product's going, it's very important for people to be measuring these volumes and these exchanges and transfers very accurately. So measurement comes into the equation here. So on the stabilized liquid crudes, we're pumping them, yes. We can inline meter those and inline meter them very well, very accurately. You can do that metering via mass or volumetric measurement. But we categorize this scenario into custody transfer on the crude oils and the condensates, where those are a raw commodity between two knowing parties and the regulatory groups, versus refined products, where is a different category or a different tier of measurement or requirements, very specific set of requirements you need to meet for that transfer of ownership or exchange. And in Canada, it's measuring Canada entity, NIST in the US, and then NOMS and et cetera in Mexico. So there is a nuance there, but certainly inline measurement for both applications, similar equipment, similar accuracies and things, but there's a slight difference between crude and condensates versus true refined products, your diesel, gas, and ethanol.
That's right. And there'll be a difference again on the LPG front, will there not?
Yes, so here's the other big break point for engineering folks is when we're going to transfer between rail and truck propanes and butanes, but let's stick with propanes today, we are not recommending, or we are not inline metering. There's a lot of challenges in that from a accuracy standpoint, the economics of trying to do that. You've got to realize that you've got a rail car, for instance, that's at 120 pounds of pressure, and you've got a truck that's at 0 pressure. You're going to connect those in a closed loop fashion and open the valves and gain the initial transfer of fluids through pressure differential. You're not going to be able to measure during that scenario. And then again, at the end of the transfer, when you're emptying the rail car, you're going to have two-phase flow again. So we just don't go there.
Inaccuracy.
Yeah, you're not going to meet any form of legal for trade accuracy in that. And if you try, you're going to spend a lot of money trying to get there. And typically a transload scenario, when it's a manifest scenario of rail car and truck only, you're going to weigh scale that. And you're going to go back, you're going to use a weigh scale to get your mass tare. Then you can do your density, temperature, and pressure corrections to that to get a volumetric value, or you're going to gauge your rail car and execute it in that fashion. Now, as for the small print, when we do truck to bullet into facility exchanges, bullet to truck, or rail to bullets and things, you can start to meter that inline, but you now need to manage, and it's a lot more complex than a weigh scale on a manifest scenario. So certainly in your facilities and higher, more sophisticated applications, we're doing inline measurement, but not typical on a manifest transload. So like I said, basic fundamentals, and we've executed on all forms and fashions, whether that be a large terminal with permanent infrastructure and inline measurement of the propanes and the vapor legs, both the liquid and the vapor legs, to the applications out on a basic manifest rail siding. So that's where we can get in more depth conversations in the future if you like.
So you've discussed that a little bit. We're using different equipment then obviously to transload and meter a diesel versus an LPG. I think we'll hit on that maybe on the next one.
Certainly, yeah. I think we're going to get to examples of, okay, so quite simply, basic pictures of the modes of transfer. You know, on the liquid side, we talked about pumps, and on the high vapor pressure or propane side, we talked about compressors. And really the compressor is doing a pressure differential. We're going to hydraulically move that liquid propane through a pressure transfer from one vessel to the other. And again, our first webinar does a great job, I believe, of describing that. There's some visuals, and we go through it very well. Yep. Now, you know, not all things for all solutions. You know, if you get into cold weather butane applications or their transloaders, we add a pump because the pressure properties of butane are going to keep it in a liquid state. And now you need to pump it. Yeah. So, which
all day long, no problem for us managing that piece. Yeah.
We do that, certainly. So again, quick little examples of metering. So we talk about inline metering of our refined products, our crudes and condensates. This sort of equipment comes into play at a base, and we've got more pictures here to show you in the builds. But you're going to start to incorporate a lot of times we call them presets or flow computers. They're really the control center, if you will, or the digester of all the signals from the measurement equipment and the controls equipment to run the pumps, the flow control valves, and to take in the measurement signals.
Yeah, it's the brains of the operation.
Absolutely. You've got that central controller. You're going to see it on the transloader examples here soon. And that's where all the sophistication is. That's where the operator goes to input information and to get information back. And there's a set configuration or a set logic to execute the transfer and measurement. And that, in the refined space, it's very prescriptive. And it's as prescriptive with the regulators and know that we have to physically lock out these units, so that can't be changed. And it's a very managed application. And at the end of the day on refined products, what you're trying to do here is maintain the integrity of measurement, not only for the government regulatory and taxation purposes, but for the final consumer, the unknowing parties. And the partner-to-partner exchanges leverage that. And it works out very well. It's very well known in Canada, the US, and Mexico, and very well documented. It can be executed over and over again with very good repeatability and reliability. So examples of the measurement equipment you're seeing dead center is the Corry meters are they're very much in favor for the liquid side, crudes, condensates, and the refined liquids. The beauty of these is they're robust. There's relatively no moving parts, if you will. They can handle the roughest of crudes and environments, and your maintenance requirement on them is low. There's a price to pay for that and a cost factor, so there is some cost to it. The other benefit of the Corry technology, of course, is it's a multivariable device. You're certainly going to have a mass flow rate value or flow rate value. You're going to have a density variable generated by the device, and then you're going to generate a temperature of your flowing product And then through those three variables, you can calculate the volume of the fluid they're moving very accurately. And so they're a fantastic device. They're low on the maintenance end, and you get multiple variables out of them automatically. There's just a price to pay on that. Now on the bottom left, you got an example of a more traditional turbine meter. Very high precision turbine meter for the refines, very relevant, typically priced favorably, but it is a single value device in the sense that it's going to give you a volumetric flow rate via signal only. You're not getting the benefit of density and no inherent temperature that you might get.
Have to be corrections come in after that.
Yeah, so you know, and it is a physical moving mechanical device that will have wear, and you can have mechanical issues, but typically in your refines products, it's not as frequent as you might find in the crude and condensate side. The other little guys up there, you'll have a temperature transmitter, pressure transmitter. When you're trying to calculate the volumetric flow rates and of your liquid commodities, you're certainly going to need your temperature and pressure values in most applications to do the accurate corrections of the measurement to compensate for shrinkage and etc. So very well known set of standards on that, configuration templates, and all of your presets are fully capable of executing those tasks. But yeah, so a little smattering of what equipment you're going to be looking for on refined product and your crude and condensate applications. Your crude and condensate applications, typically through API and through our Canadian standards, don't have as high a bar or as not as detailed in prescription at times. So we do see some differences in how we design systems there. So.
We do have another question here, hey?
Sure. Oh, we got one here from James again. Do you see challenges in proving Coriolis with a small volume provers, and how are those addressed? So, proving Coriolis meters with small volume provers, what are the challenges, and are there any, and how are they addressed? Well, at the end of the day, in the proving applications, again, what we find is your crudes and condensates are a little more volatile condensates, if you will. Probably are going to present some challenges that you may not see in your refined products, which are stabilized. For example, if we're in an upstream application with condensates that are seeing pressure and temperature drops, then we may see two-phase flow. That can affect the performance of the Coriolis meter. It's not an issue with the Coriolis meter, it's an issue with the process conditions. You may not see that two-phase flow or tendency to flash the light hydrocarbons on a diesel because it's much more of a stabilized product, right? A much lower vapor pressure. Now, how does the small volume prover, is there an issue with that? Potentially. I tend to lean on the small volume provers in the crude oil side, where if you've got a dirtier crude with solids, you may start to see issues with your small volume prover and the effects of those solids. Or heavy, viscous, waxy crudes. Yeah, that's gonna cause that can play a part. So to associate small volume provers with Coriolis, I think there's times also where flow rates and things may play a part, but typically the small volumes are doing a very good job. So I'm going to do a little transition here. Okay, so we talked about transloading. We tried to slice and identify how we would categorize transloading of hydrocarbons to design and build the right solution. We need to do that, and I hopefully I was able to communicate why that would happen. Crudes and condensates in a liquid state versus propane. Now I'm going to transition into what are some of my options when I am handling these sorts of products, your crude oils and condensates. Here we go. So let's look at a rail to truck or truck to rail application of crude and condensate, and here's a transloader, right? Here's an example of a physical asset that will do that custody transfer measurement and will allow you to do that form of movement. This is in a manifest portable application. You're seeing the components at a fundamental level. This is a independent package that has its own generator. The HMI and flow computer, which is the operator interface, that's where he goes to put in information and get information back. It also holds all of the logic to run the system safely and to protect the equipment and to do the proper measurement. So that's really the control function or spot. Tethered to that preset will be a ticket or bill of lading printer, if you will, or generator, or you can have a radio link to a terminal system, because you've got to have a physical, you need to have evidence of the transaction.
Of that transfer.
Certainly.
Yeah.
For the operations group that day, and the truck driver needs to have that as well. So I like to call these autonomous systems. The power is on it, you got lighting, you've got the pumping, you've got the measurement, you've got all the safety control systems like the grounding and overfill protection devices. So in this case, you can see the cane probe at the top of the rail car. This application was production volumes coming to the rail car, clean oil, and what you don't want to do is overfill the rail car. So a second layer of overfill protection is the physical cane probe device that will detect liquid if you've gone in excess of what you expected to.
Yep.
Say, for instance, yeah, so instance, this car you might have had, the way that you would execute that is you're making the assumption or confirm that the rail car is empty when you did your inspection. And then you're going to have prescribed volumes through the preset filling that rail car. And you're going to have an additive function where you say, if this rail car is 100 cubes, I'm going to fill it to 90 cubes to be 90% full. I can only take 3 30 cube offloads. So I might offload 30 cubes of product from the truck into the rail car, and I'm going to stop. The preset stops. Then I bring another truck and we do that again. So with the accurate measurement, I know I'm at 90 cubes of transfer very accurately. If there was no heel in that rail car, then I should have 10% of space available. And if that works for me, I'm comfortable. I may have my cane probe or my overfill protection device physically set at, say, 95% of that rail car. That is a protection. As if I made a mistake and I put in more than 30 through my preset, if I made a mistake and there was a heel in the rail car, I didn't notice.
So you have another level of safety operating for you.
Yeah, absolutely.
For your operators. And your,
absolutely.
Yeah.
So that device is feeding to the flow computer, which will shut the system in. So it's a secondary level of protection, and that's very common when in these transload applications. What else do we have here? Well, of course, you're seeing the lighting, you're seeing the vent return. So this is a vapor balance system. So we connect to the top of the rail car off the vent connection. So, and then the other hose will be connected to the truck vapor space. So we're doing a vapor balance application. We're moving the liquid out of the truck into the rail car, but we're balancing the vapors between the two containers.
All the while tracking.
And all that's really happening here is we have a connection pipe. So it's literally, you're connecting directly from the vapor space of the rail car to the top of the truck. You're seeing in this case a Coriolis meter. You're seeing in this case, again, the liquid pump. And this is a vane pump in this application. And other components that you'll see in the metering portion of this is air elimination to ensure you do not have air or gas phase in your Coriolis meter, which is the enemy of the Coriolis meter's accuracy. The Coriolis meter either wants clean gas or complete fluid. It wants single phase flow to perform optimally. They do have some abilities to deal with small presence of gas, but it's very hard to control that. So mechanically moving the air around the Coriolis meter with air elimination is a requirement of both the crude and condensates and as well the refined fuels standards and regulations. So air elimination is very much built into the design. Okay, and then there's a power component. So there you have a crude and condensate truck to rail, rail to truck transloader. I'll move to the next example. Let's go. Oh, so what you're seeing here is an example of a manifest transload being scaled. Truck, one-to-one truck to rail, and just add more transloaders, add more trucks, add more rail cars, and you're moving more volumes.
This thing was running 24/7 at the time, pretty much.
You bet, yeah, this is
Yeah.
a really nice example of a Permian project, a multiple site project, and they did a fantastic job for a short period of time.
Yeah.
And that's very typical for transloading, especially portables, is rapid deployment of capital, quick setup, and add the operations component, and you're moving volumes.
Yeah.
You can put that to bed just as fast as you started it as well.
That's right.
You shut the site down, you move your equipment out, and you're done. And this was an example. We did it 4 terminals for 1-year term. So again, still in the low vapor pressure liquid state here of transloading, a variety of products, of course. Now in the refined fuel space, still inline metered and still pumped. And we'll try and show some examples of what a transloader might look like. And we're going to move a little bit away. We're going to graduate on from portable transloaders on trailers. You're seeing all the same sorts of equipment. In this case now, we're using load arms, the grounding overfill protection, very similar builds, air elimination, very similar as to the crude and condensates.
Lots of sophistication here.
Now we're stepping up our game here. So I'll try and describe what's going on here. This is, again, a manifest portable transloader of refined fuels, but we've added some more equipment to the mix here. You're seeing a rail top access gantry. So in the prior slides, the operations group would go up the ladder of the rail car. In this application, they've got the benefit of the gantry and access up the rail, the top of the rail car here with this equipment, and it's a phenomenal thing. It just costs money, right? So you've got to gauge your requirement of do I need to outlay the expense of the rail top access gantry? And there's times where we're not offloading rail cars from the bottom, we're offloading rail cars from the top. So in that case, you most certainly need the gantry. Where we do see the gantry being defaulted a lot of times is in the cold weather climates, Canada and the northern US. It's difficult to ask your operations groups to day in and day out climb the side of those rail cars in the winter and do what they need to do. So right away the gantries are in play. Again, we've got the genset. So this is an autonomous system. You pull it to location and you're running. Grounding overfill protection again for both the rail side. So we're grounding the rail to the rail track, the rail grid, the rail cars, and then we're also grounding to the trucks on the truck side. It's very similar flow computers, pump. Now what you're seeing here in the refines, you're seeing additive tanks, storage tanks, additive injection equipment. And there's times when we're doing small dousing additives of different products into the gasoline. We got to realize that these trucks are last mile. So for instance, if you're running last mile on a diesel, you might be adding a red dye, for instance. It's a small level or a small volume of product, but it's critical and it's very well managed and prescribed. Now the other things you might be putting is other secret sauces of refiners, some of the different agents and things that they want to use. It might be in a diesel, it might be an anti-gel agent through the winter. So we're adding tankage and storage, we're adding pumping and metering on these injection components to the transloaders again. Very typical of permanent applications. It's just now being brought in a portable fashion. Again, from a basic level on a refined fuels application, you're going to have a digital control valve or a valve to control the flow in a very prescribed format, because we when the profile, and this is very prescribed through the refined fuels guidelines, you're going to wet the container at a certain flow rate, then you're going to accelerate your flow, and then you're going to end your flow. Yeah. Okay, so here's examples of a refined fuel unit, a little more equipment. Again, another gantry style unit. These literally get, we design and build these, of course, in Canada. They literally get pulled all over North America to site. They're a little tall to put on a low boy trailer, but you drop the hand railing and it meets the envelope to get on the highway. Now let's transition to stationary equipment. So in this situation, if you've got a set of rail cars and a manifest application, again, you might put a header system in between the rail car and these stationary transload units. So you can think of just taking it off of the trailer, putting it permanently on the ground, connecting it to a piping system. The piping system connects to the rail cars. And here we go, we step up the game a little bit here. We've got multiple additives, we've got multiple header connections, and in this application, we're blending as we physically fill the truck.
That's right.
For instance, you might be blending up to 15% ethanol as you fill one compartment. That truck's off to deliver gasoline with an ethanol blend.
Beautiful.
So, not only are we are there transloading on trailer units and pumping and measuring, their stationary equipment or modular design and build. Really nice example down in Mexico of a Jet A application. So all forms of those commodities you're able to execute. Okay, so propane, let's make the leap from low vapor pressure liquids and to the high vapor pressure applications. So here we go with a higher bar of engineering. First off, from a safety perspective, we're dealing with a pressurized product, and 300 ANSI piping systems. There's an expansion rate. There's a real safety component here that you need to start with. And we certainly, from a design and build perspective, we come with a safety focus first in our engineering group, and then we move on to performance and reliability. So in this application, things that you're going to want to key in on when you're dealing with high vapor pressure products, and it's prescribed, is things like bulkheads and the compressor for moving it through pressure differential. And then there's a variety of safety systems. That could be the actuated valves and snappy joes on the rail top side where we're going to isolate. We've got the breakaways and things. So again, if you go back to our first webinar, we dove deep into all of that, all the regs and specs. But this is an example of a propane transloader where you can physically move from truck to rail, rail to truck, and it is autonomous again. The genset goes right in this spot here, so you literally can pull that down the highway. And the benefit of the compression system versus a pumping application is if you've overfilled your rail car, for instance, if you're going truck to rail and you've overfilled your rail car, how am I going to get that propane out of the rail car? With the compressor, you can achieve this. And you also get the benefit with the compressor of vapor recovery. If you're going from rail car to truck, you can pull the heel down on that propane car to under 0.5% heel.
Which is big.
So you're pulling on the vapors and literally depressuring that rail car, filling trucks to maximize your transfers and your commodity. Some more snapshots. You can see the access gantry. The same access gantry as in the refines is used on the LPG, and this is electric over hydraulic, so this ramp hydraulically moves in and out and articulates up and down. There's more rudimentary systems. This is just an example of where you can go to with the equipment. So it's all in the name of efficiency, it's all safety of your operations group, efficiency of your operations, and performance throughput, right? It's all about moving that product. More examples. Okay. So we've got, I would say, a few minutes, and I'm just going to sort of run with a quick blur here of transitioning from transloaders, the different types, the different applications, some of the little fundamental things to talk about, to how we see facilities being designed, whether that's portable, modular, or large unit trains. and how transloaders can play a part in that. And again, some of the high points here on those trailers, you can see rapid deployment, low cost of capital, not a lot of engineering to get you going, and bang, there you are. In this situation, a beautiful frac site was now being leveraged for crude oil volume movement. Well, that's an 80-car lineup. That's a beautiful thing. And now what you can do is execute these transloaders. All you need is transloaders and trucks and your operations group and the volumes, and you're working, right? And I want to move more of it, faster, lots of it, scale it. More transloaders, more trucks, more rail cars. So the geometry of this location allowed for that. So this at the end of the day is how we play a part in the early stages of people moving into areas or during short-term deployments, right?
Quick solutions.
Yeah, and what are the factors? Geometry of your location, how much volume do I want to move, how many hours a day am I going to work, do I have good truck flow, right? You got to connect the logistics of truck and rail and align that with the quantity of transloaders that you have. We're going, the movement of the product, if you want to talk about performance, you can really think about somewhere in the neighborhood of anywhere from 300 gallon per minute to 400 gallon per minute. So about a cube a minute to a cube and a half a minute, very, very typical and very acceptable flow rates in and out of the trucks and the rail cars in these applications. For us, graduating that to now the next step, well, here's challenges, like it's intensity of operations and volatility of the trucking. But I'm going to move into the next layer where our clients have taken us through time is I need to move more efficiently. I need to move more equipment. I have a small location. How am I going to do this? I have multiple products. So that's where the modular builds start to play a part, where now I'll start landing maybe single pipe headers, multiple pipe headers in modules, and I'll leave the transloader stationary and I'll move the rail cars and the trucks. But I can connect to a variety of rail cars at any one transloader unit, and that's through a multiple header scenario. So
how many headers?
We've gone up to 4. We've gone up to 4, and sometimes we're blending one commodity into the other. Sometimes 3 of those are 3 different products. It could be premium, regular, and a diesel. And then we might have a blend, right? It's really up to the client to what suits their applications, what they're trying to achieve. So, the trailer looks a little bit simple at times, just a pump and a meter. Things ramp up real quickly when you start doing inline blending and multiple commodities and additive injections and things. And we've got examples here where we're 2 compartment trailers, we're crossing arms, and this is a benefit to the client, right? At the end of the day, they were able to achieve the higher volumes and the production throughputs without building a big facility. So modular manifest is what we call that. Then of course, more traditional, if you want to lose the highest volumes with rail and truck, you start moving into unit train permanent builds, right? And there's methods of executing that, modular formats, etc. But now we're talking. Now we're moving 70, 80, 90 rail cars, permanent infrastructure, maximum efficiency, optimizing your operations groups. This is what it's all about. But as you can see, highest capital equipment, complexity of design, and then construction equipment. So that's when we talk about transloaders and the small to the big, there's a variety of ways to apply. So I think we're getting close to some Q&A. Hopefully we did a good job of giving a clear explanation of transloading of hydrocarbons. And hopefully we were able to give you some examples of options, whether that be crude, condensates, refined liquids, and some propane. And a lot of times it could be, what's driving that is your business case, right? Do I need to do it for a short period of time? Is it a small amount of volume? Or am I here, for instance, and a lot of our friends in Mexico are doing serious volume commitments for long-term builds. And they're going from ship to tank to truck. And that's still transloading. And it's the same pumps and meters for the most part. Sometimes it's just bigger, right? Bigger pumps and meters.
We got one more question here, I believe.
Okay.
I think under.
Get my. Sorry guys, here we go. Which one do we want to grab here?
Just down on the comment on the present philosophy.
Okay. This is, can you comment on the preset philosophy in unloading a truck to the rail car? Is there a preset volume, or is the controller set up so that the truck is unloaded until it's empty? Okay, great question. So examples of that, let's do refined products first, for instance. On the refined products, hopefully there's an understanding of what your truck is holding, and you'll put in a prescribed volume. For instance, let's say again it's 30 cubes. I'm going to offload 30 cubes or 30,000 gallons, as another example, 28,000 gallons, from this tanker truck. I know I have it in there, I'm going to move it. That preset, you put that in as the operator, it will offload that near exact, within a liter or so, near exact, and it will stop. Now, what if there is still some volume in that truck? The transloaders can certainly give you the capability to jog it through, and then the thing to keep in mind there is, are you going to capture that in your bill of lading? Are you going to generate a second bill of lading? So what you may want to think about is prescribing a little more volume than what you think you have. And in our transloaders, we have, so what you're going to do is you're going to offload more than what's there. So you're saying, well, now you're going to cavitate my pump, you're going to get poor measurement. Well, what the system should be able to do is recognize the two-phase flow through the Coriolis meter, through the air eliminator action, through those sorts of control devices to say, okay, I didn't get what I thought I wanted to get. I wanted 30 cubes, but I'm at 28, and now I'm starting to go dry. I'm getting two-phase flow. I'm going to stop. And I think, hopefully that answers your question. If I wanted to drain that rail car, so you'd overprescribe the volume slightly and allow the transloader to recognize through the signals and control system that we're in two-phase flow state. Therefore, either you're doing something wrong on the suction side or you've ran out of product. So that's typically how we handle that. And yes, certainly the presets are there to take in the prescribed volume that you're trying to move. So that's one operational way to handle that. Okay. All right. Let me scroll here and see which ones we got. Okay, James. All right, James. We're probably going to have a phone call soon, James. It's awesome. Is it common to use sampling systems in the crude transloading from truck to rail? If there are multiple truck customers into some railroad, how do you handle? Okay, so I think really what he's asking here is, I've got a truck to rail car scenario, I've got a transloader, I want to sample what that truck gave me. So there's a variety of ways that we handle this. In the example that we had in the Permian, what our clients or operations group would do is they would take a physical hand sample, and they might take that throughout the offload. And it was for a variety of reasons that they would do that, on product quality from their customers, and at times is to monitor, say, the product quality. First off, water content. The other thing that we do on our crude and condensate applications is we'll put water monitoring devices on, so that if your truckload is wet, we're going to reject the load, if you will. We might have a bit of a timeout because your first portion might be wet, but we're going to reject a wet load. So that's an online application. But sampling of the product to get a product quality captured sample representative of what the client gave me. Some clients will do it physically and multi-part sampling, or we can put on, and we put on sampling systems that are volume weighted and pace weighted to the volume rate, so that, say for instance, for every cube or for every X gallons, we're going to capture a certain volume of that product into a container. And we do that. So the second part of that question, so that's a piece of equipment you would add to the transloader if you want to do it automatically, and it's sophisticated enough that it's paced and it's volume weighted, if you will, so it should be representative of what you gave me. Now the next question is, I'm in a terminal. If I have multiple trucks and customers coming into the same rail yard, how do you handle that? So really, if again, as long as you're doing, if your sample point is far enough up on the suction side and your composite sampler has an ability to be purged, you should be representative of the volume that you captured in whatever container that you used represents that person's offload from truck to truck. So it's more an administrative function. Now you're saying, okay, we also do things on water management in the bill of lading. That will be associated to whoever brought the volume as well. So that's captured digitally. So if you said, hey, if we were water monitoring you and it was a little bit wet but didn't overstep the set point, that could be on your bill of lading. That bill of lading is associated to that LSD and that truck driver and that customer. So that's how you would handle it from the more data side of things, or the preset. The physical jug filling is going to be an operational task, right? He physically has to reset, purge the sampling system, and then take that sample, label it, and associate it to that client's volumes. So that's what I can recommend there from what we've seen, yeah, in a terminal application. Okay, guys, well, we blew through an hour. Pretty awesome.
I do want to say, don't forget to subscribe to our YouTube channel, yes, and also to follow us on LinkedIn. We're hoping to be doing more of these coming forward, hopefully, you know, and we would love to hear some of your suggestions on topics that you would like to hear John speak to or our team speak to. So please feel free to reach out to us. Thank you to everybody that joined us today.
Yeah, we had a really big list. I love it.
Yep.
And we're gonna get better, smarter, and have more fun with our webinars. And if you've got more questions and things or suggestions, bring it on. And we'll keep doing it. Thank you very much.